Hi guys, so we'll be doing the AMC10 and B from 2004, problem 24. So the question is, in triangle ABC, we have AB equals 7, AC equals 8, and BC equals 9. Point D is on the circumscribed circle of the triangle so that AD bisects angle BAC. What is the value of AD over CD? So first of all, we have to draw out the circle, and then we have to label and draw out the lines. So now we have to draw out the triangle. And now we have to label. So now we have this, we also now have to put in what it says over here, the D. So what we're trying to find is, so we're trying to find AD over CD. So first of all, we have to find over here. So first we can use the angle bisector theorem, which is simply B over M equals C over N. So in this case, we have 7 as the B, and C is 8. So we can use that, and we can find out we can find out AD over CD because we have because of similarity. Well, this will be actually a later step, but remember the angle bisector theorem for now. First of all, we have to use similarity. So we can put over here this angle as E, this point as E. So this one, we have this one. This angle is going to be congruent with that one. So which is because we bisected that. This angle over here will be equivalent to this angle over here because of the arc over here. Because in a circle, when we have like this, we have a triangle like this. Usually these angles would technically be the same. It's kind of difficult to explain, but so anyways, because we have these two angles are equal, we can use the AA similarity. And we can find that ADC equals ABE. So we know AD over AB or 7 equals CD over BE. So first we have to revert these. So we know that AD times BE would equal 7 times CD. So we simply divide CD and BE. So now we have 7 over BE equals AD over CD. So after this, wait, hold on. So I might have made a little mistake. Let me backtrack really quickly. And no, never mind. So as I was saying, so because of this, because that we have now found the similarity, we can use the angle bisector theorem I was talking about earlier. So the angle bisector theorem is, as I stated, B over M equals C over N. So in this case, the BE would be the B. The BE would be the M. So we can just put M over here. And the E and the C over here would be the N. So now we can replace this with 7 and C with 8 because of this and over here. The whole reason the angle bisector can work, by the way, is that we have bisected this angle over here, which means that the value over here over BE would have to equal AC over this point to C. So anyways, we also know that M plus N equals 9. So we now can substitute, which is M equals 9 minus M, N. So, and over here we have 7N equals 8M. So, because of this, we also know what M is, so we have 72 minus 8N. So 7N will equal this. So 15N equals 72. So N equals 72 over 15, which is over here. So, however, we're trying to find BE for this one. So we have to, 9 subtracted by 72 over 15, which would be 63 over 15. So because we know that, so now we know that what M is. Because now we know what, so now we know this. We can replace BE with 63 over 15. So which would be 7 times 15 over 63. Which means that we can cancel this out and replace this with 9 or 15 over 9. So, AD would equal 15 over 9, and in simpler terms, it would be 5 over 3. So the answer to this question is B, 5 over 3.